let's start with the fetal and maternal side of normal placenta. So there are two sides, right, of the same placenta. One is towards the fetus, so it is called as the fetal side, and one it is towards the mother, that is called as the maternal side of the fetal placenta. Now, let us just tabulate the differences. First, the fetal side of placenta. The fetal side of the placenta, and we have the maternal side of the placenta. Maternal side of the placenta. Now, the fetal side of the placenta, repeat. Now, the fetal side of the placenta, it forms 4 by 5th of the entire placenta, whereas the maternal side of the placenta, it will form 1 by 5th of the entire placenta. Right? Now, the next difference, the fetal side of the normal placenta, it is formed from chorionic frondosome. It is formed from the chorionic frondosome. And remember that the maternal side, it originates from the decidua basalis, right? So, it originates from the decidua basalis. Now, the fetal side of the placenta, it is covered by fetal membranes. It is covered by fetal membranes. And remember that it is shiny grey in color, right? It is shiny grey in color, whereas the maternal side of the placenta, it is dull red in color, right? It is dull red in color. Now, the fetal membranes, basically they give it a shiny grey color to that, and yes, the maternal placenta, it is dull red in color. Apart from that, remember, if suppose that this is the fetal side of the placenta, the cord will be attached to the center. The cord will be attached to the center. So remember, the cord, it is inserted at the center, right, in the fetal side. And as we compare to the maternal side, you know, maternal side has polygonal areas. They have polygonal areas. These are like these areas which are there. Yeah, they have polygonal areas, and these polygonal areas, I have already told, these are called as the lobes, right? And each lobe, it is further divided into cotyledons. It is further divided into cotyledons, right? Approx 15 to 20 cotyledons are there, and remember, the cotyledons, they are the functional unit of placenta. They are the functional unit of placenta. They are the functional unit of placenta. Right. Now coming on to the next one, that is the uteroplacental and the fetoplacental circulation. Now when I say uteroplacental, it means that the circulation is between uterus and the placenta. Blood circulation, it is between the uterus and the placenta. And when I say fetoplacental circulation, it means that the circulation, it is between fetus and placenta, right? Fetus and placenta. Now, remember there is something which is called as intervillous space, right? You already know. Let us suppose that this is the placenta, right? This is the placenta, and in the placenta, in between the placenta, we have the intervillous space. Intervillous, these are the villi, and yes, in between the villi, it is the intervillous space, and there is, okay, now let us answer this question, that the volume of blood present in the intervillous space. Intervillous space, it is around, yes, it is around 350, or sorry, repeat, the volume of blood which is present in the intervillous space, it is around 150 ml, right? And inside the villi, now these are the villi, right? These are the villi, right? This is also villi. Now, this is the volume of blood present in the villi. It is around 350 ml. 350 ml. So, if I ask you the total volume of placenta at term, right? If I ask you the total volume of placenta at term, it is 150 plus 350 ml, that is around 500 ml. That is around 500 ml. Now you already know we have uteroplacental and fetoplacental circulation, right? Now let us just try to tabulate it. Yeah, again, uteroplacental circulation, and we have the fetoplacental circulation. Fetoplacental circulation. So, remember the uteroplacental circulation, it is present in the intervillous space, right? It is present in the intervillous space. Intervillous space, right? So, remember the oxygen saturation over here, it is around 65 to 75%. 65 to 75% in the intervillous space, right? Now, it is the number, the spiral arterioles of like the uterine arterioles. So, remember the number of spiral arterioles which open into this intervillous space, it is 120 in number. Now, if we talk about the uterine or the uteroplacental blood flow at term, at like 40 weeks of pregnancy at term, it is around 400 or like 450 to 650 ml per minute. It is 450 to 650 ml per minute, right? Now, when we talk about the fetoplacental circulation, now you already know the fetoplacental circulation, it is established between, okay, it is established between day 17, it's like starts on day 17, right, and it completes on day 21, okay, it completes on day 21, and the fetoplacental blood flow at term, it is around 400 ml per minute, okay, it is around 400 ml per minute, right, it is around 400 ml per minute. So yes, suppose this is the placenta. Now you already know, suppose this is the placenta and we have the fetus with us, right? We have the fetus with us. Now The fetus say deoxygenated blood, it will go to the placenta. Deoxygenated blood, it will go to the placenta, and from the placenta, what will come to the fetus? That is the oxygenated blood. That is the oxygenated blood that will come. Oxygenated blood is coming via umbilical vein. It is coming via umbilical vein. Okay. And what is the oxygen saturation of umbilical vein? It is like 70 to 80%. And deoxygenated blood, it is coming via umbilical artery. Okay. Umbilical artery. And see, the oxygen saturation of umbilical artery, it is less than the oxygen saturation of umbilical vein. So the saturation of umbilical artery, it is around 50 to 60% only. Okay, it is 50 to 60% only. Now we will discuss about the functions of the placenta. The very first function you already know, that is the respiratory function. The respiratory function of the placenta, right? Now we already know about the respiratory function, right? You already know the placenta allows the exchange of gases, right, between the fetal blood and the maternal blood, right? The placenta allows exchange of gases between the fetal and the maternal blood, right? You already know the oxygen diffuses from the maternal blood to the fetal blood, and CO2 like diffuses from the fetal blood to the maternal blood, right? Now the second function that you have to know, it is the nutritive function. It is the nutritive function. So you know it allows the passage of nutrient substances, vitamins, minerals. So it allows substances such as the nutrients, right? Vitamins, important minerals from the maternal blood to the fetal blood. Okay, from the maternal blood to the fetal blood. Now, apart from that, remember, it also performs the function of excretion. So, it has excretory function as well. It has excretory function as well. So, it allows the diffusion of nitrogenous products, for example, urea. Okay, it allows diffusion of nitrogenous products example urea. This urea basically from fetal blood to the maternal blood, from fetal blood to maternal blood. Apart from that, it also performs the secretory function, or I will say the endocrine function, right? It also performs the secretory or endocrine function, as it releases various hormones, right? It releases various hormones. You know, it is the estrogen, progesterone, human chorionic gonadotropin, and human placental lactogen, HPL, right? So we will be discussing each of these hormones in detail, no need to worry, right? Yes. And apart from that, placenta also performs the protective function. You know about the placental barrier, right? Protective function. The placenta also performs the protective function, the placental barrier that we have talked about. So it prevents the passage of most of the organisms to the fetus. It is not allowed to enter the fetus. So this placenta basically acts as a barrier. Not all, but yes, most of the microorganisms are prevented from entering, right? So this placenta acts like a barrier. The placental membrane, they act like a barrier. Now, discussing about the placental hormones one by one. So you already know the four hormones that we have discussed. HCG, that is the human chorionic gonadotropin. Then we have HPL, human placental lactogen. The third one, that is the estrogen. And the fourth one, that is the progesterone. The fourth one, that is the progesterone. So let us discuss one by one about these hormones. The first one, that is the HCG, that is the human chorionic gonadotropin. Remember, it is produced by the syncytotrophoblast, right? So that is, you have to remember. Now the second point regarding this, the alpha subunit of this hormone is similar to LH, FSH and TSH. Luteinizing hormone, follicle stimulating hormone, and yes, thyroid stimulating hormone, right? TSH. The third point, see, it maintains the corpus luteum of pregnancy. It is the function which is similar to LH, right? It maintains the corpus luteum of pregnancy and function is similar to LH. The function is similar to LH. Now, the doubling time of ECG, the doubling time of HCG, it is around 48 hours, right? It is around 48 hours, right? This HCG basically appears in the maternal blood after 8 to 9 days of fertilization, right? So remember that HCG appears in the maternal blood after, yes, 8 to 9 days of fertilization. 8 to 9 days of fertilization. So it is approximately day 22 of cycle or day 23 of cycle. अगर 14th day को, for example, this is the first day and this is the 14th day. If suppose on 14th day ovulation is taking place and fertilization is taking place. So 8 to 9 days after will be day 22 or day 23 of cycle, right? It will appear day 22, right? So that is the day 22 of cycle, that is 5 to 6 days before the missed period, right? Before the missed period. Remember, the HCG, it peaks at around 9 to 10 weeks. 9 to 10 weeks, okay? It plateaus at 16 to 20 weeks and after that it will remain the same, right? And then it remains in the blood low level like throughout pregnancy, right? So that was about the HCG. Coming on to the next one, that is the HPL, that is the human placental lactogen. So remember, it is produced by Syncytiotrophoblast only. It is produced by Syncytiotrophoblast, right? It is produced by Syncytiotrophoblast. It is similar to growth hormone and prolactin. It is similar to growth hormone and prolactin. So remember, it is detected earliest. It is detected earliest at around 3 weeks of pregnancy, right? At 3 weeks of pregnancy. Now, the maximum production of HPL, it is around 36 weeks of pregnancy, right? So, this is again you have to remember the maximum production of HPL, it is around 36 weeks of pregnancy. And remember that it is responsible for insulin resistance in pregnancy, right? You already know that the fetus requires glucose for its growth. It is the only fuel that is available to the fetus for its growth and development. So it is developing the insulin resistance in mother, so that all the blood from means all the glucose from the mother, it can go inside like to the fetus. So yes, remember that it is responsible for insulin resistance in pregnancy. That was about all about the HPL. Now coming on to the progesterone. Progesterone, remember, it is produced by the corpus luteum. It is produced by corpus luteum till 6 to 7 weeks, right? It is around till 6 to 7 weeks. Now, after 8 weeks, it is produced by the placenta, right? After 8 weeks, it is produced by placenta. Okay. Now, it prepares the endometrium for implantation and it decreases the myometrial contractility, right? Obviously, I have discussed this before also. So, it prepares the endometrium for implantation and it decreases the myometrial contractility. So that was about the progesterone, and the source, it is the maternal LDL, right? Now coming on to the estrogen. So remember, the most specific estrogen in pregnancy, the most specific estrogen in pregnancy, it is E3, right? It is E3. Most common in pregnancy, it is E2, right? Now, placenta cannot synthesize its own estrogen, okay? So, it requires precursor. Placenta cannot synthesize its own estrogen and it requires precursors from the mother. Repeat, from the fetus. From the fetus, right? Now, fetus, you already know the fetus, they have the fetal adrenal glands. Fetal adrenal glands, basically they give DHEA S, yes, DHEA sulfate, right? DHEA sulfate, which is used by placenta to form estrogen. So this is used by placenta to form estrogen. So yes. Now, if I ask you for the initiation of labor, this fetal ACTH is required, right? So that was about all the hormones. Now coming on to the next, that is the placental anomalies. So in short, I'm going to discuss about the placental anomalies. So you already know that the normal placenta, it is attached to the upper uterine segment. It is attached to the upper uterine segment, right? It is attached to the upper uterine segment. If it is attached to lower uterine segment, then it is called as placenta previa. Placenta previa. So usually the placenta, it is attached to the upper uterine segment, but if the placenta, it is attached to the lower uterine segment, then it is called as placenta previa, right? This is placenta previa. Now how to remember this? Previa, p पहले आ जाता है placenta, ठीक है? So yes, again another thing that you have to remember, normally, what is normal? Normally the cord, it is attached to the center of the placenta. The center of the placenta. But if cord is attached to, right, if it is attached to the margin, okay, if it is attached to the margin of placenta, it is called as battledore placenta. Okay, if it is attached to the margin of placenta, then it is called as the battledore placenta. Okay, or lateral insertion of cord. Lateral insertion of cord. So for example, if this is a placenta, normally the placenta is attached to the center, but if the cord, it is attached to the margin, then it is called as the battledore placenta or lateral insertion of cord. Now coming on to the next anomaly. Now let us suppose, let us draw a diagram and understand. Yeah. Now this is the uterine cavity, right? Uterine cavity. And let us suppose that this is a placenta. This is the placenta. And this placenta, right? There are two parts over here. So remember, okay, if part of the placenta, if part of the placenta, basically it detaches from the main placenta. It detaches from the main placenta. What will happen then? But these two parts are connected with each other through blood vessel, right? But connected with each other through blood vessel. So this is called as circumcuriate placenta. This is called as circumcuriate placenta. This is called as the circumcuriate placenta. Now let's take up another case. Let's take up another case. If suppose this is the uterine cavity, right? This is the uterine cavity. Now, if there are two equal parts of the placenta, now let me draw this. If suppose this is one placental part and this is another placental part, there are two equal placental parts, okay? They are connected by blood vessel, okay? They are connected by blood vessel. So, remember, two equal placental parts they are connected by blood vessels. They are connected by blood vessels. So this is called as placenta bilobata, right? This is called as placenta bilobata. Okay, two lobes you can see, and both the lobes they are connected with each other through blood vessel, right? Now let us assume some another case that suppose this is the uterine segment, right? This is the uterine segment, and there is one big part of placenta and there is another small part of placenta, and both of them they are not connected with each other by blood vessel. So there is one big part and one small part, right? And they are not connected by blood vessel, not connected by blood vessel. So this is called as placenta spuria. It is called as placenta spuria, right? Now, placenta bilobata, circumcuriate placenta or placenta spuria, they both can lead to postpartum hemorrhage, right? They are all the ones which can lead to postpartum hemorrhage, right? Now, if the fetal site of the placenta is small. Normally, the fetal site of the placenta is 4 by 5 and maternal site it is 1 by 5. Now, let us suppose if the fetal site of placenta, let us suppose this is small and the maternal site it is big. Maternal site it is big, right? In this case, the fetal site of the placenta will be surrounded by the maternal site, right? So, in this case, fetal site it is surrounded by maternal site, right? So this is in the form of such a way that it forms a ring, okay? So that is, it is called as the extracorporeal placenta, right? This is called as the extracorporeal placenta. Extracorporeal placenta, okay? Now remember, the extracorporeal placenta, it is of two types. It is of two types. We have circummarginate placenta, and circumvallate placenta. Circumvallate placenta, right? The fetal site is, it is surrounded by a maternal site, right? The fetal site, let's suppose this is the fetal site, it is surrounded by the maternal site, okay? And yes, there is a valve like, okay, if there is no valve like thickening, if there is valve like thickening in between, then it is called as circumvallate, right? If there is no valve like thickening, it is just a you can say a smooth part, so that is it is just in the form of a ring, that is called as the circummarginate placenta, right? Let's now talk about the vasa previa. The vasa previa, okay? You already know this is the uterine cavity, and let us suppose this is the developing fetus, right? It is the fetus, and we have the placenta over here, right? This is the, let us suppose this is the placenta. Now, you already know the developing fetus is, it is covered by a membrane. Now, the placental cord, it is first attached to the membrane and then it is attached to the fetus, right? So, remember, the cord is first attached to membrane, okay, first attached to membrane and then it is attached to fetus, okay. In this case, this is called as the filamentous insertion of cord. Filamentous insertion of cord, and this is something which is referred as the vasa previa. Vasa previa. Now, what are the complications, guys? You already know at the time of the labor, the membranes will rupture, right? These membranes are basically attached to these cords. Now, the cords, the umbilical cords, they are carrying what? The umbilical arteries and the veins. Now, they will also rupture. So, blood loss will be there. So, again, it can lead to fetal death. So, this is something very, very important. So, that was about the placental anomalies that we have talked about, right? So, placenta previa, battledore placenta, circumcuriate, placenta bilobata, placenta sporia, extrachorial placenta, circummarginate, circumvallate, and vasa previa. Now, coming on to the umbilical cord, let's in short discuss about the umbilical cord, right? Let's in short discuss about the umbilical cord. Now, the umbilical cord, it develops from the connecting stalk. I have already told you the connecting stalk, it is holding that embryo, okay, proper, or the embryonic plate, it's actually holding that embryo. So, remember, it is developing or it develops from the connecting stalk, right? The normal length of the cord, the normal length of the cord, it is approximately around 30 to 100 centimeters, right? If it is less than 30 centimeters, then it is called as the short cord, right? pH of the cord, it is 7.2, okay. So, yeah, umbilical cord has got two arteries and one vein. Which vein? It is the left umbilical vein and two arteries, right umbilical artery and the left umbilical artery, right? Right, the right umbilical vein later on will disappear, and what is left? Left umbilical vein is left, right? So that is at the time of the birth, only three vessels are there. So yes, that was about the placental anomalies. Now coming on to the monozygotic and dizygotic twins. So remember that if a single sperm will fertilize a single ova, then there will be formation of a single zygote. So monozygotic twins, they are formed from single zygote, right? They are formed from single zygote. They are also called as conjoined twins, right? Whereas if there are two ovas which are released by two different ovaries at the same time and two sperms are like fertilizing that, so there will be two zygotes that will be formed, two zygotes that will be formed. So the monozygotic twins, it is more common, and the dizygotic twins, it is least common. Least common. The monozygotic twins, they are genetically identical. They are genetically identical. And the dizygotic twins, they are genetically not identical. They are genetically not identical. Right? The monozygotic twins, they have same sex, but the dizygotic twins, they can have same sex or they can have different sex as well. Different sex as well. Right? Over here, you will find the two amniotic cavity, but it has one chorionic cavity, right? It has one chorionic cavity. They have two amniotic cavity and two chorionic cavity. Okay. Now the monozygotic twins, they have only one placenta. They have only one placenta. And the dizygotic twins, they have two placenta. Okay, they have two placenta. Now, when I say chorionic cavity, beta, you already know it is the extra embryonic coelom. Extra embryonic coelom. So, one, it is in the case of monozygotic, and two in the case of dizygotic twins. Thank you.